Welcome back, everyone. In the last time we talked about molecules and mass percent, and now we're going to take that one step farther and say, let's say we're given information about the masses of some samples, we want to be able to find the empirical formula. So this is working the other direction. Before we had the formula and we found the mass percent. Now we're going to go the other way. Take the masses and find the mass percent and then the molecular formula. So in order to be able to find a molecular formula, we would need to know what the molecular weight is of our sample and then compare that to the empirical weight of our sample. So, for example, if we wanted to find the molecular formula of a molecule, it has an empirical formula of CH2O and a molar mass of 180 grams per mole. Well, we know that the empirical weight of CH2O can be found. You add together the mass of the carbon, the hydrogen, and the oxygen. That gets us 30 grams per mole. Then, by taking the ratio of the molecular weight to the empirical formula weight, so the weight of that unit, we can find how many of those units are needed. And so that is 6. So that means then, instead of having CH2O, it would be C6H12O6. And again, that's because we took the ratio of the actual molar mass to the empirical formula unit mass. So if we're given, we could give you information about the elements and ask you to find the empirical or the molecular formula. So let's say perhaps we're going to look here at a scenario of a compound that has carbon and hydrogen and oxygen. And so we can tell you you've got a certain number of grams of each element. Find the empirical formula. Or maybe we tell you the mass percent of an element, and we want you to find the molecular formula. So this method that I'm going to demonstrate is the way to convert, is the way to determine either to determine the formula of our molecule using the information given about how much of each element we have. This is essentially the reverse of what we did before when we found the molecular formula and we found the mass percent of each element. So the first thing that you'll want to do if you're given mass percents of an element is to assume that you have 100 grams of sample. And the reason is because our masses should add up to be 100%. So if you say I have 100 grams of sample, it makes the calculations very easy. We can then use the atomic weights and the mole ratios and the molecular weight to find our molecular formula. So let's go through an example here. Let's say that you have an ibuprofen tablet. It is 75.7% carbon and 8.8% hydrogen by mass. And we're told that it's composed only of carbon, hydrogen, and oxygen. We're given the molecular weight of ibuprofen, and we want to know what's the molecular formula. So we're told what the mass percent is of carbon and hydrogen. Notice that they don't add up to be 100%. Therefore, we know that the remainder must be the mass percent of oxygen. So to find that, we'll take 100% and subtract the mass percents of the other two elements. That will then get us a mass percent of 15.5% oxygen. At that point, we can take those mass percents and we want to now find, in the end, how many moles of each element there are so we can take the ratio of them. So if we just arbitrarily assume we have 100 grams of the sample, then it's very easy to determine the mass of each individual element. You could have said that we only have 5 grams of sample, but then the calculation is a little bit more difficult, and you would it's harder to tell that you've done it right. So the mass percent will convert directly to the mass of that sample, assuming we have 100 grams of that sample. So now we know the mass of each sample. We can find the moles of them. And again, what we're trying to do is if we're looking for the molecular formula, we need to know what is the whole number ratio. And in order to find that whole number ratio of the elements, we need to find the moles of each element. So we can use the molar masses, or the atomic weights, to convert from grams to moles. For carbon, it has an atomic weight of 12 grams per mole, as found on the periodic table. Hydrogen is approximately 1 gram per mole, and oxygen is 16 grams per mole. This now tells us how many moles of each element we have. From there, we need to take the ratio of those elements to each other. And again, the reason for that is because we're looking for what is the actual ratio of one element and the other within the ibuprofen. What's the ratio of carbon to hydrogen or carbon to oxygen? And my recommendation is that when you take that ratio, that you take the ratio of each element to which as a ratio to whichever other element is the lowest value. So for example, oxygen has the least number of moles. So when you divide the number of moles of oxygen by itself, you'll get a value of 1. If you were to divide instead by take the ratio of carbon to carbon atoms, then we would get a fractional number for the number of moles of oxygen. So in order to find the relative mole ratios, the simplest thing to do is to divide by the element with the smallest number of moles. So for carbon, we see that the ratio of carbon to oxygen is about 6.5. For hydrogen, it's about 9. And for oxygen, it's of course going to be 1. Now the problem is that the empirical formula must deal only with whole number ratios. So the fact that we have 6.5 carbons to 9 hydrogens to 1 oxygen isn't good enough. We need to know instead the whole number ratios. So we can't just say that for every 6.5 carbon atoms there's 9 hydrogens. We have instead to convert these to whole numbers. So the easiest thing to do is to take whichever element is not a whole number and multiply by some number such that we get a whole number from it. So what number do you need to multiply 6.5 by to get a whole number? Well, the answer there is 2. So if we take this ratio and we multiply everything by 2 in order to get whole numbers, we get C13H18O2. This is our empirical formula. If you wanted to double check that, what you could do is you can add up the empirical to get the mass of this and find the mass percent of each element. That would reverse what we just did, and we know how to do that from the previous videos. Now, if we want to find the actual molecular formula, we need to take the ratio of the molecular mass to the empirical mass. So to take that ratio, we first need to find the empirical mass of C13H18O2. That's found by taking the mass of 13 carbon atoms plus 18 hydrogen atoms plus 2 oxygen atoms, and we get 206 grams per mole. So when we take the ratio of the molecular weight to the empirical weight, we see that it's a 1-to-1 ratio. Or in other words, the empirical formula is the molecular formula. Okay, now let's see if you can figure this out. Go ahead and try this on your own. Pause the video and then come back and I'll walk you through it. Welcome back. So in this question we have a hydrocarbon. It says that a hydrocarbon is an organic compound that's made up only of carbon and hydrogen. And we want to know if we have a 0.1453 gram sample of it, and it's 85.63% carbon, 14.37% hydrogen. What's the empirical formula? What's the lowest whole number ratio? Well, to do this, let's start by assuming that we have 100 grams of a sample. The reason to do that is, again, because it makes the calculation of the mass of each element easy. So we would have 85.63 grams of carbon and 14.37 grams of hydrogen. We then convert that to moles by using the molar mass. That would get us about 7.13 moles of carbon and 14.26 moles of hydrogen. Now, we generally here will want to leave out as many sig figs as you can in order to not get rounding errors later on. So now that we know how many moles of each we have, we need to divide by the lowest number of moles. That will get us a whole number ratio for at least one of the elements. So if we divide by the moles of carbon, we see that there's one carbon atom for every 2 hydrogen atoms. That then gets us the empirical formula CH2. So that's our empirical formula. Now, you try this one. If we're given the molar mass, what is the molecular formula? Assuming that the empirical formula is CH2. Pause this and try this on your own. Welcome back. So, what do we need to do here? We need to find the empirical weight, or the empirical mass of CH2, and compare that to the molar mass. So to find the empirical mass, you take and you add the mass of 1 carbon to the mass of 2 hydrogens. That gets us 14.027 grams per mole. When we take a ratio of the molecular weight to the formula weight, we see that that is a 2-to-1 ratio. And therefore, our molecular formula is going to be 2 times the empirical formula. And so that would get us C2H4. Okay, that's it for this video. I have this slide up for you to indicate to you that there is a third movie for you to watch. Dr. Bojan put together an excellent video where she goes through similar types of problems what we just did here, but for combustion analysis. This is a particular process that you'll need to be familiar with, and so you should watch that video as well. Thanks for watching and have a great day.